Charles from GMAT Ninja here. Welcome to episode number 17 in our comprehensive GMAT Quant series. Today we're going to be talking about statistics and problems where we have to minimize or maximize something. What I want to emphasize right out of the gate, this is a non-technical approach to it. So we're going to try to give you really good coverage of all the different questions about statistics, mean, median, range, standard deviation that you might see on the GMAT or the executive assessment. But I'm going to come at it from a non-technical angle. So I'm not going to bombard you with a ton of formulas. We're going to talk about what are the concepts you really need to understand to master these questions. So if you've never taken a stats class in your life, you should be able to catch a lot of what we're doing here. And by the time we're done, you should be able to handle some pretty tough questions. If you've taken a lot of stats and you know all the formulas, that's fantastic. This video might still help you a bunch because we're going to help you understand those concepts a little bit more deeply and more importantly, be able to apply them in kind of the ways the GMAT and the EA tend to test it. So topics here, we're going to be talking about mean, median, and range, but I'm not going to walk you through the basic definitions. I'm going to assume that you know these three things, but I'm going to talk about the kind of pitfalls that you can run into on the GMAT and EA that involve these terms. I'm going to talk about questions where you have to minimize or maximize something. So for example, you might be asked for the least possible value of the greatest number in a series. You see that all over the place on the GMAT overlapping sets, for example, we talked about it. Statistics is kind of where you tend to see it the most. So we're going to talk about those and kind of get those reasoning skills really, really strong so that wherever you might see it, statistics or beyond, you'll be able to handle those questions. Weighted averages, not anything that's super complicated there either, but we're going to show you a really nifty shortcut that'll get you through those questions without doing a ton of algebra. We're going to talk a whole lot about standard deviation. And again, not going to bombard you with formulas. I want you to understand how it works, how to manipulate it. And when we start manipulating a set of numbers, what happens to the standard deviation? Because that's the most common thing you're going to see on the GMAT or EA. And again, the emphasis here is going to be conceptual, not technical. Yes, we're going to go through some pretty tough problems, but you don't need a super strong technical understanding, just a really deep conceptual one. So who's this video good for? Obviously, if you're missing foundations, you've never seen stats before, hopefully we'll help you out here. If you know the formulas, but you still struggle, you look at the actual questions on the GMAT or the EA, and you're not quite sure how to penetrate them, or it takes you a really, really long time, you're in the right place. And again, this is going to be mixed difficulty. A lot of our videos, we kind of progress from easy questions to harder ones. That's not quite what we're doing here because stats is kind of this collection of concepts. They don't always fit together perfectly. So you might struggle on standard deviation, for example. You'll see some of those questions later in the video. You might have a really easy time with mean and median or minimum maximized problems. Those are going to come earlier in the video. And you might find that the three questions you struggle with the most in this video, one's in the beginning, one's in the middle, one's at the end. So please stick with us. If you struggle with any of these questions, feel free to skip around, fast forward as you need to. And one thing I want to emphasize here, stats is a pretty big topic on the GMAT. So about 7% of questions on the GMAT, about the same on the EA, are going to be statistics of some sort. Some of them are very simple algebra questions that happen to include the word mean. Some of them are much more conceptual. So this is a pretty big chunk of the test. So it's a pretty important topic. There's no way we can cover every single variation in a 1 hour video, but I'm going to try to get you through the really key things that you're going to need in order to get at the concepts. And with that, we'll launch into our first example. All right, as always, feel free to hit the pause button if you need a little more time to work through this one. So fairly straightforward question. And again, most of what this video is going to be about, especially the first few questions, it's typical pitfalls. These aren't super technical things. You know what a median is. It's the middle number. If there's an even number of terms in the series, you're looking at the two middle numbers, taking the average of them. Really, really simple concept. So how does a GMAT disguise that in a way that makes it challenging or makes it possible to induce an error, even if you didn't feel like it was a hard question? Really, really common thing we see. For most people, they kind of glance at this and their first instinct is, oh, yeah. It's got to be, we've got sort of 5 different sets of numbers here. It's got to be right here. So that median has to be somewhere in that 401 to 600 range. So my answer is C, and I'm out of here. And look at me. I did the question in 20 seconds, 30 seconds. I saved some time to go focus on the harder ones. Watch your back. A bunch of things that I just did there that are a mistake. One is I missed the question. Second is just don't try to save time for the harder ones. That doesn't work very well. If you feel like something's really, really easy, watch your back, read the question twice, check your work, see if there's some way you could have done something that wasn't quite on point. So when you're looking for the median, here we got a whole bunch of numbers. Great. How many do I have? The numbers are kind of rigged here really nicely, which is pretty typical of the GMAT also, by the way. If you see a fairly big chunk of numbers that you need to add up, there's usually going to be some sort of shortcut there. Or they're going to make the numbers not so bad in the end, or you can estimate them or something like that. Very typical GMAT. They're not really looking to torture you with really complex arithmetic here. So I'm going to kind of do whatever I can to make this easy on myself. 65 plus 45, that's 110. I can kind of see that these digits are going to add up pretty easily here. I got 33 and 57 is another 90. Looks like I got 200 terms. Beautiful. So my median is going to be right between the 100th and the 101st term. So from here, I can just kind of eyeball this a little bit and go, well, where's that going to be? If I start from the bottom, I see that I've got 102 terms just in these last two ranges, which means that my median has to be right here. And again, a couple different ways you can look at it. So 102 terms combined among the higher two ranges. So median's got to be in that next to last one. I can also look at this and go, well, that's 98. Median's not there. It's got to be in this next one. So my median is in this range right here between 601 and 800, which means my answer must be D. Again, typical GMAT, not technically hard. I've seen a lot of really, really strong students who have the skill to get something like a 47, 49, 50 on the GMAT mess up on something like this. When you see something like this and you get that feeling that, oh, that's really easy, just watch your back, double check, make sure you're counting the numbers carefully and not falling into the trap of saying, oh, the median must be in the middle range. It's the middle number of each of the terms in the series. All right, let's give you one more. Hopefully a little bit more challenging. All right, as always, if you need a couple more minutes, feel free to hit the pause button. So very, very typical style of GMAT question here, at least conceptually. So these kind of minimize, maximize problems where you're being asked to find the least possible value of the greatest number, that sort of thing. You see it all over the place on the GMAT. Overlapping set, certainly you see this kind of thing, as well as other sorts of problems. This is one of the most common variants of it. They give you mean, they give you median. Nothing super technical here. You know what mean is, you know what median is. They turn into a nice little reasoning problem. To illustrate the concept, I'm going to pretend for a second that there's just 3 homes. I think I'm just going to follow some intuition here. So median is 135,000. Great. No need to put the thousands in there. What am I being asked for? Being asked for the least possible sale price of the most expensive home. So I'm trying to minimize this guy up here. And you probably already realized that this is kind of a zero-sum game. So if the average is 150,000, it means that the sum of these three values has to be 3 times that, so 450,000. Okay, so I'm trying to minimize the biggest one. And the only way for this to make any sense is if I maximize this guy. So I find the biggest value of the smallest number. That's going to lead me to the smallest possible value of the biggest number. So what's the biggest I can make this? One of the mistakes I see here quite a bit, depending on the way the question's framed, people might be reluctant to say 135 here. Now notice there's nothing in the question that says that these need to be different numbers. So no problem in repeating a number. So if we have 135, and whatever this is, your median's 135. It doesn't matter which one is the median. It's 135 either way. So no problem repeating numbers unless they tell you otherwise. So pay careful attention to that language in this type of question. Now all we have to do is a little bit of subtraction. We got it. So 270. So 450,000 minus that 270. So for this variant on the question, we get 180,000 as the smallest possible value of that largest number. Now, that's not the question we were asked. Now we've got 5 homes, but it's the same concept, just a tiny bit more complicated. So now we've got 5 of them, same deal in the middle, still going to be 135. We're still trying to minimize this, which means we're trying to maximize everything else. So if we're trying to maximize these first two, once again, doesn't say anything about not repeating the numbers. So these have to both be 135. And now this is the one that can get a little bit tricky. What does it mean to maximize this? Well, what's the biggest we can make this? The biggest we can make this is the same number as that. So if you want to use a variable here, you can say, well, this is x, this would also be x. And now I've got a nice little equation I can solve. So sum here, 5 times 150,000. So 5 times 150,000 gives me 750,000. And off we go. 135 plus 135 plus 135 gives me 405,000. Plus 2x gives me 750,000. And if you do the math here, we end up with 2x equals 345,000. So x has to be 172,500. And our answer is D. So plenty of variants of this. The fundamental principles behind it are basically the same. You're just thinking through, okay, take a moment, breathe, think through, what am I maximizing, what am I minimizing? Follow the logic from there, watch the language carefully, make sure that you're paying attention to whether they tell you can or cannot repeat numbers. All right, we'll give you one more that's kind of the same flavor, and then we'll move on to some other concepts. All right, hopefully this one's not so bad after the last one, but can take another minute if you need to. Hit the pause button. Okay, so once again, giving you 5 different numbers, and we want to know the greatest possible sale price of the least expensive book in this case. So I'm going to start with kind of the obvious part. If the mean is 12, that means the sum has to be 12 times the number of books times 5. We got $60 is going to be the total sum of the prices. And now, once again, no shame in kind of writing this out, kind of make it a little bit more visceral for yourself and listen to the numbers a little bit. Don't keep it all in formulas. If it helps you to kind of draw it out and see the sequence, go for it. So I don't have a median here. All I have is the range and that mean. So I could say something like, well, this is, I know the lowest one is, let's call it X dollars. If the range is 10, range, if you haven't run into it before, it's just your largest minus the smallest. That's it. So I know that my biggest one has to be X plus 10. And now the only part that's hard from here really is just thinking through what exactly am I minimizing? What am I maximizing? So if I want the greatest possible sale price, least expensive book, so I'm trying to maximize this. So if I'm trying to maximize that smallest one, then what am I trying to do to the rest of these in the middle? I'm trying to minimize all of them. And again, nothing here about different prices. So they could all be the same, or 4 of them could be the same, certainly. So what's going to be the smallest these could be? Well, just X, right? So if I repeat the same number 4 times, great. I get 4 that are X. These are minimized. That's going to maximize this guy. And all I have to do is the math here. So add these up. So X plus X plus X plus X plus X plus 10 gives me that sum of 60. So 5X plus 10 equals 60. And X just has to be 10 here. My answer is C. Again, plenty of variance on this, but this is the heart of it. Just take a moment, think through what exactly am I minimizing, what am I maximizing, and whether it's in the context of stats or some other topic, that's really all you need to do is just take a breath and think through that, and you've got it. All right, on to the next concept. Give you guys a couple minutes. All right, as always, if you need a little more time, hit the pause button. So this is one of those questions, again, nothing super fancy here, just a pretty straight question about averages. We see a ton of mistakes on it, though, and I think the reason tends to be that there's a temptation to formalize this question a little bit and create this really complicated tangle of equations and not anchor yourself enough in the intuition. And if you look at this question and kind of go, okay, let me think about this in kind of relative terms, really root myself in kind of the underlying just understanding of what's going on here. You don't need any variables at all, as it turns out. So we've got race number 1. Mercedes is 2 seconds slower than Elon. I'm just going to express this in relative terms and say, okay, well, her time is 2 seconds extra. So plus 2 seconds there on that first race. Second race, same idea. She's 7 seconds slower. So plus 7. This is what we're being asked for. We want to know how much faster was she in the third race. And really once you kind of think about it this way, the only real hitch in the question is, what is this total? What's that total difference between their times? Well, she's 6 seconds faster on average than Elon, which means that across 3 races, she must be 18 seconds faster cumulatively. So 6 seconds per race on average, 3 races, 18 seconds slower total. I'm sorry, 18 seconds faster total. So her time overall is going to be minus 18 relative to Elon. Once you see that, we're basically done here. 2 seconds slower, 7 seconds slower. How much faster does she need to be to get to a cumulative total of 18 seconds faster? So 18 plus that 9, this has to be a minus 27 for it to work out. You can double check the numbers. 2 plus 7 minus 27, we get minus 18. And our answer here is 27. And we're out of here. Is it a mistake to do this with a bunch of variables? Could you make this e plus 2 or e1 plus 2 and e2 plus? You certainly could. Nothing's stopping you from doing this. But there's really no reason for it. If you don't need the variables, don't punch the variables in there. Just think about it intuitively. And these questions clean up really, really quickly. All right, on to the next one. All right, if you need another moment, feel free to hit the pause button as always. So this is one of my favorite kind of GMAT stats questions, partly because it doesn't feel like statistics at all, right? It's a bunch of percentages and that's kind of it. The concept here in kind of a subtle way is that it's about weighted averages. And part of why I like teaching these questions, first of all, they show up quite a bit on the GMAT and the EA. But second, it's the kind of question where we see just this huge range of errors and kind of error types from students on this. Sometimes people look at this and just go, well, wait a minute. The question itself is talking about, so it says 70% of males received negative review, 38% of females received negative review. And then it kind of goes on to talk about negative reviews. How's that going to tell me what percentage are male? The answer is E, I'm out of here. Some students apply a ton of algebra and get themselves stuck and don't get anywhere. Some students apply a ton of algebra and they get the answer right, but it takes them a long time. And some students kind of fall into a different trap where they kind of think they need more information than they really do. All that's to say is that there's a fairly simple, fairly intuitive way to go about these. So I'm going to jump right into statement one. So 42% of all employees receive a negative review. And the concept here is that we know what percentage of males receive negative reviews. We know what percentage of females do. If we know the percentage of all employees, that's actually all we really need. And to kind of illustrate that, let's pretend for a second that instead of 42%, that this is 54%. And I chose that number because it's smack in the middle of these two. And just think about it logically. So if 70% of men receive bad reviews, 38% of females, and on average, 54% of the entire company receives a negative review, well, that tells you have to be balanced between men and women in the company. There's no other way for that to make any sense. There's no way that you would have more men or more women if that weighted average is smack in the middle. Similarly, if we had exactly 70% receiving a negative review company-wide, that would tell you it's all men. If it was 38%, it would be all women. And the GMAT loves to play with this concept. There's some great questions floating around out there where they kind of get at the idea that, well, company-wide, it can't be more than 70%, can't be less than 38%. They'd love to kind of come at this in a conceptual direction. And if you find yourself kind of doing tons of algebra, you're going to kind of miss the point. So again, the intuition here is once you sort of know those endpoints, you know that 38% of the females get a negative review, 70% of the males. As soon as you know what percent of the whole company does, it's going to tell you the proportion of men to women in the overall population of the company. So in this case, we could say, okay, it's 54%. And if you were doing this as problem solving, so I'll come back to the 42% in a second. We'd kind of say, well, all right, what's the difference between the 70% and the 54%? That's 16. This is also 16. And it turns out that distance between the weighted average and the endpoints, that ratio is going to tell you the ratio of men to women in this case. So when it's smack in the middle at 54%, we know that the ratio of men to women is 16 to 16 or 1 to 1 or 50-50. Well, now if this is offset a little bit, we can get at the same exact concept. It's just going to be a different answer. So now it's 42%. So kind of step one here, I'm just going to do a little bit of subtraction. This is 4. 70 minus 42 is 28. So first of all, the intuition here that you should be anchoring yourself in is I know that I have more women. Has to be true, right? So if the weighted average is closer to the average for the women, it means I've got more women in this population. So I know I've got more women. And then I can kind of subtract here to get the ratio. And I know that my ratio of men to women here has to be 28 to 4, which I can reduce to 7 to 1. And one last little step here, if you're doing this as problem solving, just be really careful. I want you to carefully combine step 1 and step 2. Step 1, intuition. Ask yourself, what's there more of? There's more women here because that weighted average is closer to the women's average. Subtract, I get that ratio. I carefully combine these two just so I don't flip these around and decide that it's 7 to 1 men to women. In this case, it's 7 to 1 women to men. And that gives you everything you need. You can turn that into a percentage. So 7/8 of the total are women, which means that 87.5% are female and 12.5% male. So as soon as you know that weighted average, that tells you the answer. Statement 1 is sufficient. We can cross out B, C, E. Now, to be fair here, this is more math than you would need to do in reality. Once you understand the concept that knowing that weighted average is going to tell you the proportions of the two populations, you don't need to do all this math. I'm just showing that in case you're into one that's problem solving. This is the way to go about it. Step 1, anchor yourself in the intuition. What do I have more of? Step 2, do a little bit of subtraction. That's going to tell you the ratio. Step 3, just watch your back. Make sure you're not flipping it around because that's one of the most common errors I see. People will say, oh, it's 28 to 4, and that's men to women, which obviously doesn't make sense because we have more women. And again, if you're looking at this as data sufficiency and you just recognize right away that that's all the information I need, no math required, you can cross out B, C, E, and off you go. On to statement 2, by itself, just know the number of employees doesn't tell us anything about the relative ratios of men to women. So we can eliminate answer choice 2, and your answer is A. Okay, so that's weighted averages. Sometimes some tests where people call them mixtures, whatever you want to call it. Again, it's another one of those classic GMAT stats questions. Anchor yourself in the intuition. If the algebra is already working for you, great. For most students we run across, better just kind of do it intuitively. Draw yourself a little picture. Stay anchored in what's going on, and don't overdo the variables. All right. So we're going to guys this principle, and it'll show up in a question a little bit later on. Now we're going to start to tackle standard deviation, and we could go totally crazy pants on this. I could spend a whole hour and a half getting the standard deviation. I'm going to give you 3 different variants, mostly kind of getting at the concept underneath it. And we'll talk a little bit about what do you really need to know technically about standard deviation, and what are the things you can kind of ignore and still do just fine on the GMAT and EA. Give you guys a couple minutes on this next one. All right, as always, feel free to take more time if you need. Hit the pause button. Okay, first of the standard deviation questions, we're going to go through 3 of them today. And one of the things that we grapple with quite a bit internally is the question of, if you're taking the GMAT, how deeply do you really need to understand standard deviation? Do you need to know the formula for it? Do you need to be able to calculate it from scratch? So indulge me for a few minutes here. I'm going to talk about standard deviation on kind of both the formulaic and intuitive level, and talk about what do you really need depending on what your goals are on the GMAT. So we could get super technical here, and I could give you the formula for calculating standard deviation. It's this monster sigma notation. And what you're doing is you're taking every observation, every number in the data set, you're subtracting the mean from it, you're squaring those, you're adding those up, and then you're dividing by the number of terms. Got it? Do you think you're gonna have to do that on the GMAT? I'm betting you absolutely will not. I don't think there's ever been a problem where you have to just take a bunch of numbers and calculate standard deviation from scratch. If this is something that you've seen, maybe in kind of the fine print of the official guide, or you've seen it in a textbook somewhere, please don't worry about it. If you've already learned from your previous studies how to calculate standard deviation from scratch from a bunch of numbers, good for you. That's awesome. You're probably going to have to do it in your stats class in business school. But it really doesn't have a lot of value on the GMAT. This is too formulaic. The GMAT's after your reasoning skills, not how many formulas you've memorized or whether you can apply a formula with pinpoint precision. Not their deal. Don't worry about this. They're never going to give you a bunch of numbers and say, with no other information, calculate the standard deviation. Notice that in this particular question, they gave it to you. Standard deviation is 9. That's all you need to know. So don't worry about the question of how do I calculate it. Second, there's, I think, one question in print, maybe 2, of all the official questions that have ever been released of the several thousand, that requires you to kind of understand that standard deviation and variance are related to each other. Standard deviation is just the square root of variance. If that's something that makes your head hurt, don't worry about it. The odds that you see it on your actual exam are really, 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 really slim. Again, 1 or 2 questions ever released out of thousands of quant questions. Extremely unlikely. Don't worry about it. If you took stats, let's say in undergrad, and you happen to know that, wonderful, hang on to it. The odds that it's a problem for you are super, super, super slim. So I wouldn't worry about that either. What I do want from you, whether you're new to standard deviation, new to stats, or not new to it, is understanding on a more conceptual level. So when we're talking about standard deviation, we're talking about the average distance from the mean, or put more intuitively, how spread out are the numbers in a data set. So the kind of thing you very well might see is, I'll give you 4 numbers in the first list, and how about 4 numbers in the second list? And they might ask you, hey, which of these has the bigger standard deviation? Well, these numbers are more spread out, right? So these sets are very, very similar. This one has more numbers outside. This has the bigger standard deviation. So that might be a really, really basic question you would see involving standard deviation. In theory, they could kind of give you something where they give you something like a distribution. So in this case, I drew a normal distribution. And they might give you one that's kind of, fairly tight, and one that's maybe a little bit more spread out, and say, all right, which of these has the bigger standard deviation? Well, it's the one that's more spread out, right? So a lot of the questions they're going to ask you are conceptual. So as long as you understand that basic concept, you're in pretty good shape here. Now, with all that said, this particular question is actually asking you just to kind of apply it on a more basic level. They give you the standard deviation of this set of numbers, and they say, well, how many of those values are more than 1.5 standard deviations above the mean? So just a little bit of math there, and nothing too awful. One friendly reminder, whenever you see a big list of numbers on the GMAT, there's always a shortcut. There's always a way to kind of make it easier on yourself. They're not going to give you, such heinous brute force arithmetic that you're going to suffer a ton on it. A lot of ways you could do it if you just want to write out the 12 numbers and, add them up by brute force, knock yourself out. I'm kind of looking for ways to combine things a little bit and go, all right, are there numbers that kind of add together nicely? For example, I might take the 12 and the 28 out and go, well, all right, that's 40. And then I might go, all right, well, I got, where do I want to go next? I got 8 and 4, that's 12, another 18. So that's 30 again. And I might kind of do something like that. 24, 21, that gives me 45 plus 15. That's 60. And then it's got these little guys down here. 2 plus 3 plus 3. So I got 14. And I get 144. Notice they tell me that there's 12 plants here. And very, very typical GMAT. Look, it's been rigged so the numbers aren't so bad in the end. As long as I don't get intimidated by the arithmetic, I'm fine. So 144 divided by 12. Now I know that my mean has to be 12. And then we're in business. So if you haven't seen something like this before, I'm just going to walk through the logic of this a little bit. So they tell us that the standard deviation is 9. So your mean is 12. So what would it mean to be one standard deviation above the mean? Well, if a standard deviation is 9, so 9 grams of weight in these plants, one standard deviation above must be 12 plus 9, so 21. One standard deviation below, for example, would be 12 minus 9, since one standard deviation is 9 grams, and that's 3. 2 standard deviations above, 12 plus 9 plus 9, and that's 30. Again, I'm not recommending that you walk through this, but just if you've never seen this before, that's the idea. If the standard deviation is 9 grams, your mean is 12 grams. One standard deviation above must be 12 plus 9. 2 standard deviations above must be 12 plus 9 plus 9. That's the idea. And now, seriously, we've covered basically everything you really need to know from a technical perspective about standard deviation. And just to finish this guy off, so 1.5 standard deviations above the mean. 12 plus 9 times 1.5, so 1.5 standard deviations times 9 grams. And that's going to give me 25.5, I believe. So is that right? 4.5? Yep, 13.5 here plus 12, 25.5. Just have to go back to my list of numbers. 28's the only one. So just one value that's more than 1.5 standard deviations above the mean. And that's it. That is everything you really need to know about standard deviation. If you're going for a super, super high score, if you need a 50 or a 51 on the GMAT and you want to go deeper and you haven't seen standard deviation before, you could do that, I suppose. But really, this is it. Now, they're just going to combine it in different ways to kind of get at the concept. And can you think about what happens to a data set as we start throwing new numbers in there, or we start altering it in some way? How does that standard deviation change? As long as you can follow that logic, that's really all there is to it. So almost regardless of your goals, this should cover you even if you don't have a really strong background in stats. I'm going to give you 2 more that kind of get at some of those concepts in a little bit more of an esoteric way. Good luck on this next one. All right, as always, hit the pause button if you need a little more time. Okay. Now, a lot of different ways to approach this. If you've taken a ton of statistics and you know a lot about sort of the technicality of standard deviation, fantastic. What I'm about to do here is not for you. This is kind of for people who don't necessarily have a lot of the super technical foundations of statistics under their belts. And I'm going to talk about just the intuition here. And that's going to be enough for you to solve every single GMAT and executive assessment question around standard deviation. If you can understand fundamentally how it works, don't need any formulas, don't need any algebra, anything like that. Just understand how it works once you start to add something to every number in a set or multiply every number in a set by some constant. Okay, so we've got X water tanks, whatever that is. Mean is 52, standard deviation is 10. And we want to know after it rains and something happens to those tanks, what happens to standard deviation? So statement 1's saying that we add the same number, 6 gallons to each tank. Let's talk about what happens. I'm going to take a big step back and talk about it conceptually. Now imagine that it's a nice, cute little bell curve, and this is your starting distribution. Now, if we were to add the same exact number, doesn't even matter what it is, we're going to have the same number to everything in this data set. Again, standard deviation is how wide this is. It's a measure of spread. So how far apart are these numbers from each other? If we add the same exact number to everything in the set, all we're doing is we're sliding it over. It's shaped exactly the same way. I changed the mean, I changed the center of the distribution. I didn't change the shape of it. If I didn't change the shape of that distribution, I didn't change the standard deviation. So in this example, if I add 6 gallons to each tank and we started with a standard deviation of 10, we ended with a standard deviation of 10. So if that intuition lands for you, fantastic. It's all you really need for this. Add the same number to everything in the set and you got it. If it helps, I can illustrate this clumsily with some numbers. So let's imagine, just for the sake of argument, that we have 3 values in a set of numbers. It's 2, 4, and 9. Now, I want to be really careful with this. I'm not saying that the distance between numbers is going to lead you exactly to the standard deviation, but you can think of it as a proxy, right? We're measuring spread. So if this helps you intuitively, what's the difference between the first and the second number? That's 2. What's the difference between the second and the third? That's 5. What happens if I add the same thing to every number in the set? Well, now I have, let's say I add 6 to all of them. I've got 8, 10, and 15. What happened to my spread? What happened to the distance between numbers? Absolutely nothing. It's the same. This is still 2, and this is still 5. So adding the same number to each value in the set doesn't change the standard deviation. So if you're adding some constant to everything in a set, standard deviation does not change. And again, whatever way of illustrating the concept helps you more, go for it. So with that in mind, statement 1, sufficient, 6 gallons added to each tank. That means your standard deviation doesn't change. So it has to be A or D. I can cross out B, C, E. And as it turns out, it doesn't matter what the amount is. I could add 10 gallons, 20 gallons, quarter of a gallon. Makes no difference at all to the standard deviation. It changes the mean by a different amount, but it has no effect whatsoever on the standard deviation. So my answer here is D. Real quick, because it does come up, and this isn't going to appear in any of the examples in this video. What happens if you're multiplying by a constant? So let's think through that again with this example. What if I multiply everything here, let's say by 3? What happens to the spaces between numbers? So 2 times 3 gives me 6, 4 times 3, 12, 9 times 3, 27. What happened to my gaps? This is now 6. This is now 15. My gaps tripled as well. So if you're multiplying by a constant, what's that going to do? It's going to scale up your standard deviation as well. So if this said the contents of each tank was multiplied by 6, now our standard deviation is 60 gallons. So bottom line here, if you're adding a constant to everything in a set of numbers, standard deviation does not change. If you're subtracting, standard deviation does not change. But if you're multiplying, the standard deviation is going to scale up by exactly the same amount that you're multiplying every number in the set by. All right, and that's all there is to this one. Give you one more. Last standard deviation question. Good luck to you. All right, as always, hit the pause button if you need a little more time. Okay, so by now you probably see the theme here that we're emphasizing the conceptual over the technical on standard deviation, which is exactly what the GMAT and the executive assessment both do. I'm not sure there's really a way to do this with a ton of algebra. I suppose you could, but it's really just kind of, do you understand what happens to the standard deviation once you start adding numbers into a set? So here's the underlying idea. Let's say I give you some set of numbers. I don't know, being kind of random here. 79. Why not? Let's add one more in there. And now let's say I'm going to add two more numbers into this set. And I want to know what happens to the standard deviation. Now, I'm not asking you to calculate the standard deviation here. And by the way, the standard deviation is not 1. Don't confuse even spacing with standard deviation. Those two are not the same thing at all. Because think about what happens if I add a couple new numbers to the sequence. If I add more numbers outside of it, the question you want to ask yourself is, did I spread my data out more? Yeah, I did. Now it's more spread out. Still consecutive integers, but the more of them I have, the bigger the standard deviation. Now, what if I were to take this same set of numbers and instead add, I don't know, a 5 and a 6? What did I do? I added more numbers that are in the center. So my average distance to the mean got smaller, right? Because I added a couple of numbers that are very close to the mean. So that's the concept underlying this. If we add things that are outside the set or towards the ends of the set, I made the standard deviation grow. If I added things that are at the mean or very close to the mean, I must have shrunk the standard deviation. So that's the underlying idea. Nothing technical there. Just if you can anchor yourself in that logic, this question cleans up pretty quickly. So I've got 100 numbers in set M. They give me the mean, 45, standard deviation 10. Standard deviation apparently is always 10 in our problems at GMAT Ninja. Set N has 4 numbers. We're going to combine those two sets. And the question is the standard deviation bigger than 10 now? Statement 1, the range of set N is 0. And again, a lot of what we promise on this video is, yeah, it's these basic concepts. You know what range is, but can you think about it a little bit more deeply conceptually and go, well, what does that mean in terms of standard deviation? Or what does that mean in general? If the range is 0, it means biggest minus smallest is 0, which means these are all the same number. So set N consists of 4 identical numbers. Now, what's going to happen to the standard deviation of the set? Who knows, right? Because we don't know anything about what that number is. If what we're adding to the set is a whole bunch of numbers, 4 numbers that are identical and very close to the mean, then we shrunk the standard deviation. If we had a whole bunch of numbers that are way outside of it, let's say we add 1,000 and it's 4 numbers that are all 1,000, we made the standard deviation grow. We don't know what the case is here. So we don't know whether the standard deviation shrinks or grows or stays the same. So for that reason, we can eliminate A and D. Statement 1 is not sufficient. Statement 2, so wash your brains. Forget about what we just learned about the range. Statement 2, sum of the numbers in set N is 180. Well, let's play that out a little bit. It's very possible that those 4 numbers are all 45, but we don't know that yet from this alone. So is it possible that it shrinks the standard deviation? Yeah, those 4 numbers could still add up to 180 and be very close to 45. They could also be way outside of it. So for example, this could be, I don't know, 1,180, and then I don't know, what would this have to be? Negative 300 and negative 400 and negative 300. Notice it doesn't say anything about what the numbers are. It doesn't say integers, doesn't say negative, doesn't say positive, doesn't say whether they're different or the same. So we could have massively spread out numbers that add up to 180, and those are going to increase the standard deviation. So by itself, just knowing the sum doesn't tell us what happens to standard deviation. And now you could probably see the punchline already. We know that it's all the same number. 4 numbers, sum is 180. So each number has to be 180 divided by 4. And what a coincidence, that's 45, which is equal to the mean. So if we keep adding a bunch of numbers into the set that are equal to the mean, we're going to reduce the standard deviation. We're reducing the spread of that data. So with that, C is sufficient. We know that the standard deviation is not bigger than 10 now. We know that it has to be less. So we know that combined, these two are sufficient, and our answer is C. All right, I'm going to stop torching with standard deviation. One last question to finish this off. Some of you guys will find it really, really tough. Some of you guys will find it pretty easy. Have at it. All right, hit the pause button if you need a little more time on this. One of those questions can be a little bit of a tangle if you don't kind of see the shortcuts in it. Very, very typical GMAT. Really isn't a super hard question, but the issue is that if you're not kind of seeing the best ways to approach it conceptually, you might be here for 3, 4, 5, 6 minutes, tons and tons and tons of different variants of ways to attack it. But if you can see the best ones are going to be rewarded, it's actually a really easy question. Get through it in 90 seconds or 2 minutes with no problem. But if you kind of start off on the wrong foot, you can get yourself in a tangle. It's going to take you a long time. And you might also be wondering, what does this have to do with statistics? And you'll see in a second. We'll get in there. All right. So Zoo is selling 20 tickets every 10 minutes from 5 o'clock to 9 o'clock. We get the prices of the kids' tickets, price of the adult tickets, total revenue. How do we kind of pull apart how many adult tickets there are? Where I'm going to start here is how many total tickets are we selling? So every 10 minutes, so they're every hour, they're selling 6 batches of tickets. So 120 tickets per hour in theory. Be really, really careful here. The temptation is to say that between 5 o'clock and 9 o'clock, we're selling them every 10 minutes. So 6 sets per hour. So we'll say 6 batches an hour times 4 hours. Feels like we're going to get 24 of them. Watch your back. We got one at 5 o'clock, 9 o'clock. It says from 5 o'clock to 9 o'clock inclusive. If that concept is unfamiliar to you, what I want you to do, go watch. Harry has a fantastic video called Counting in Sequences. If you want more time on that concept, why is it 25 and not 24? Feel free to watch that video. Really, really helpful on that. But the thing to recognize here is that 5 o'clock, 5:10, 5:20, 5:30, 5:40, 5:50. So that's 6. 6 o'clock it started again. In that 8 o'clock hour, between 8 o'clock and 8:50, you get another 6. But then you got that 9 o'clock in there. So that's going to add 1 to it. So we actually get 25 batches of tickets, 25 batches times the 20 tickets. Nice clean numbers, typical GMAT. 500 tickets total. Okay, other useful piece of information here. We know that there's a total revenue of $5,000 from these tickets. Hey, check that out. Gave you nice, neat numbers. $5,000 per ticket divided by 500 tickets. It must be $10 average per ticket. And now if you're doing this and wondering what the heck does this have to do with statistics and the rest of what we've been doing in this video, well, here you go. Kids tickets, adult tickets, weighted average is $10 per ticket. And now this is one of those nice little weighted average problems. You can do a bunch of algebra here. It'll work. If you're super, super comfortable, super fast with the algebra, no problem, knock yourself out. For most people we meet, going to be a lot easier to do it this way. Recognize that the kids tickets are $7 each. Adult tickets, $22. Weighted average is $10. So we know that for sure we have more kids tickets. And now we just do a little bit of subtraction to get the ratio. This is a distance of 3 between the weighted average and the kids ticket price. We know that this is 12. So we have a ratio of 12 to 3, which reduces to 4 to 1. And again, just watch your back. Just be careful. What is that 4 to 1? Is that kids to adults or adults to kids? We know we have more kids here. So this has to be kids to adults, which sounds like a really difficult zoo trip. I'm challenged at the zoo when I have my 2 kids and 1 adult. 4 kids per adult, crazy day at the zoo, but whatever. All right, so we know that we want to know how many adult tickets. We know that 20%, 1/5 of the tickets are adult tickets. We know we have 500 tickets total, so all we have to do is a little bit of multiplication there. So 1/5, because 1 out of 5 are adult tickets, times the 500, 100 tickets, and our answer is B, and that's it. Okay. That wraps us up on statistics, minimizing, maximizing. Again, very kind of conceptual approach to statistics. If you got all the way through this and you love the technical stuff, knock yourself out. Really, personally, I find that enjoyable as well. You might find it really helpful in business school. And if you don't know anything about any of these formulas, great. This is really all you need. We pretty much covered all the concepts you would ever need on that 7% or so of GMAT and EA questions that are statistics. And as long as you can anchor yourself that intuition, you're going to be in great shape. All right. Thank you so much for watching. If you made it through this far, hit that subscribe button, and we'll see you in the next video.